Okay, we're going live. Hello, everyone. Welcome to this month's Research Showcase. My name is Kinneret Gordon, and I am the lead research community officer on the WMF research team. Research showcases are monthly convenings organized by our team to recognize and share recent research on or relevant to the Wikimedia projects. For those of you that are joining us live, we welcome you as always to ask questions of the speakers in the YouTube chat. We will monitor this channel and pass the questions on to the speakers at the end of each presentation. We kindly ask all attendees to follow the Wikimedia friendly space policy and the Universal Code of Conduct. Before we get started, we just wanted to let you all know that Wikimania, the annual global conference celebrating all things Wikimedia and free knowledge, is happening in Poland on August 7th through 10th. The event will also take place online, so there's no need to be in Poland, and the registration for that is free for the online version of it. You can join hundreds of Wikimedians from across the world for this event. You can learn more and register in the link that we will share shortly in the chat. And with that, I will pass it over to Isaac to introduce this month's speakers and theme.
Thank you, Kinneret. Hello, everyone. I'm Isaac Johnson. I'm a senior research scientist at the Wikimedia Foundation, and I'm glad to introduce the July 2024 Research Showcase. So today's topic is going to be machine translation on Wikipedia, and I'm very excited about this, and I think I often say that I'm very excited. But we've been doing Research Showcase for about 10 years, which means I think close to 200 presentations. And this is the first time, as far as I know, that we've had a presentation on machine translation. So I think this is a topic long overdue, but a very exciting topic. As you'll hear, machine translation has a massive impact on our content and our communities, and I'll nudge folks, and I think, Kai, you'll bring this up in your presentation, but there's some really good data sets out there as well for studying machine translation on the wikis. So again, very excited for this. And our first project will be presented by Kai Zhu and focuses on the promise and pitfalls of AI technology in bridging the digital language divide. Kai is an assistant professor at Bocconi University in Milan, Italy. His research focuses on the economics and impact of new digital technologies, such as social media, digital platforms, and more recently, artificial intelligence. He especially focuses on content provision, knowledge gaps, and the implications of more or less content and data. He's previously worked on Wikipedia, and his paper on the organized contributions to Wikipedia won the Wikimedia Research Award of the Year in 2021, and I highly recommend folks, if you haven't read it, to go find it and read it. Our second project will be presented by Saeed Alshahani and Gina Matthews on the implications of using inorganic content on the Arabic Wikipedia editions. Saeed is a computer science PhD candidate at Clarkson University in New York, United States. His main research focus is the ethics of NLP systems and their related issues like fairness and transparency. More specifically, his PhD dissertation addresses the representativeness of the Arabic NLP corpora and pre-training datasets and the related issues like underrepresentation and misrepresentation of native Arabic speakers in NLP systems, like large language models. Gina is a professor of computer science at Clarkson University, a member of the ACM Technology Policy Committee, a founding chair of the ACM Technology Policy Subcommittee on Artificial Intelligence and Algorithmic Accountability, and a chair of IEEE USA AI Policy Committee. After each talk, we'll have about 10 minutes for discussion. We'll be happy to take your questions in the YouTube chat, where my colleague Eli will monitor the chat and relay the questions during Q&A. With that, let's pass it on to you, Kai.
All right, so I'll begin sharing my screen. Okay, can everyone see my slides? Okay, good. Thanks for the invitation. So this is actually the second time I present at the Wikimedia Research Showcase. I think I present previously in 2021. So it's always a pleasure to come to this community. It's my favorite community, and getting those good comments and new ideas. Okay, so today I'm gonna tell you about machine translation on Wikipedia. And I think our study will speak to the promise and maybe also some pitfall of using this new language technology, particularly in bridging the digital language divide. So I'm Kai Zhu. I'm assistant professor at Bocconi, and this is with my co-author, Dylan Walker, who is at Chapman University. So I'll start off by just pointing out that machine translation has been a very exciting technology. We have witnessed recently the switch between from like statistical machine translation to machine translation that's powered by deep neural network, right? That's what we call neural machine translation. So that happened like around 2015 and 2016. I still remember that when Google switched their machine translation system, like Google Translate, to Google Neural Machine Translation, so suddenly it's very noticeable. The quality become just much better, right? So that is not to say the translation become perfect. It used to be it's not like it's poor quality. It's not very useful, but now it potentially can be useful in some cases. Right, so that's in 2016. Of course, then it's keep improving. So on the slides here, it still say LSTM, which stands for long short-term memory. But now all the modern system is powered by transformer-based architecture, right? Which is the same architecture power all the large language model as well as like including ChatGPT. So with this new improved ability, we also see new opportunity for machine translation. Right now, we see using the machine translation not only in content consumption stage. Now we're actually thinking about using it to create new things and like publish those contents. So here, notice example is like multilingual, creating multilingual content for global website. Our website has global audience, right? Like video subtitle, for example, for video streaming platform like Netflix, like HBO. So here, however, unlike content consumption, where just rough translation might suffice, here in content production often demand higher accuracy because for published materials, errors can undermine information reliability and also trust. Because of that, we often see a human-in-the-loop approach and where human also edit and try to improve the results from machine translation before actually publish it. So that will be the case in our empirical setting as well, which is content translation on Wikipedia. I'm sure all of you are familiar with Wikipedia. I just want to remind you one aspect of it. That is, it's not just one Wikipedia, right? It's many ones of different language. And each language edition is independently developed by its own community. So it has its own coverage and also own focus. Here on the slides, you see that English Wikipedia have the most have the largest number of articles, where we have 6,700,000 number of articles, which in Italiano Wikipedia have 1.8 million. In Chinese, it has 1.4 million articles. Right. If you think about like how content is produced on Wikipedia, right, at a very high level, the choice of editor, basically they have two options, like in a simplified version of it. The default way is to write an article from scratch, right? That's the default way, and that's the most common way has been used to create a new article. But today, I'm gonna tell about a new alternative way, which is translate from another language where this concept already exists in this language, right? We try to migrate, in some sense, to the focal language. We want to create these new articles. So here, I'm showing you this screenshot of exactly the interface of content translation system on Wikipedia. Right? It's a system developed by Wikipedia in-house to do content translation. So it's launched in 2015. So it's not really new, right? It's already been almost 10 years. It become more and more popular, and more articles are created using content translation. And here you see two articles of the same concept side by side of different language. On the left-hand side, you see this article, Colonization of Mars in English, where this article already exists. On the right-hand side, this article is not exist yet in Spanish, but this editor in this process tried to create this article in Spanish by translating it from English. So this is basically how it works. So in this study, I will leverage a nature experiment where Wikimedia collaborated with Google to integrate Google Translate into its content translation system in January 2019. So begin in January 2019, the editor can use Google Translate to create an initial translation draft from another language edition, right? Then the editor can further improve So before 2019, right, in this system, it already exists. So editor can use it, but the option to editor is either they can do manual translation by themselves, or they can use other machine translation service like Yandex, which is another machine translation service. So it was available, it's just not as good as Google, right? So now we are looking at a shock where the editor suddenly has a better translation technology. Right, so I want to make this note here because I don't want you to kind of misunderstood here. Sometimes I use term machine translation, right? But it's really, the humans still play a bigger role here, right? Editors are still important. They need to make the choice which article they want to translate, right? To initialize the process. Then also when they get the return from machine translation, they also need to further editing, correct an error, and also contextualize maybe in the focal language. So this is very much still human in the loop approach, even though I'm going to focus on the improvement in technology. Right? I don't want you to forget about this. This is not just machine translation. All right, so you might or might not aware of that, right? But it's actually already been an important aspect of content production on Wikipedia. So as of April 2022, we have more than 1 million articles created across all language with content translation system. This is a bit outdated. I think by now it's almost 1.8 million articles created with content translation. Right? So that's more than the entirety of Italian Wikipedia, also Chinese Wikipedia. So that's a lot of new contents. So the same this tool is useful, right? We have been using it to create new content. But the question I want to ask in this research is, can it be used to bridge digital language divide? And that referred to unequal access to information and results that due to language barriers. So here I list some basic facts and numbers. If you think about our internet, right? Actually, the overwhelming majority of content is only in a few major languages. And most of content on the web is only available in English in particular, right? That's the most dominant language. That is, despite that, there are thousands of different tongues spoken around the world. So that has implication, right? If you think about this, it's really kind of bizarre because for people who do not speak a primary language, internet might have little to offer, right? Even though for us, we always feel like there's always abundance of information, we cannot possibly consume even a small portion of it, right? That's because we are privileged as English speaker. That's not the case for lower results language speaker. Right. So here I have to give credit to Wikipedia. It's a better than average web, but it's still a problem even for Wikipedia. It's recognized by Wikimedia Foundation as well. So, okay. I move on here to academic research. I will be relatively quick here, given that I only have 20 minutes. So here, existing research has shown that they have documented there's a lot of different type of content gap exists, right? We realize there's a problem. So there's a gender gap, there's a geography gap, a knowledge domain gap. And research also show that organized efforts such as editing campaign are generally successful at improving the content, but they often fall short at improving their visibility. It's including my own study published in 2020. Right? But despite all that, relatively few studies have focused on the gap, the knowledge gap across language. So this is where our study today will try to contribute. So it has been quite apparent that the problem that we don't have enough content, it's because we don't have enough volunteer, right? It's difficult to get enough human resource to contribute. It's the case even for major language, but just even more of the problem for lower resource language. Right? Then the idea being proposed is, okay, if human is limited, can machine intelligence be helpful? Right? This is a particular on a topic, given that so much progress in AI. So to answer that question, I combine data from different sources, try to investigate this question. But the main data source is coming from the content translation API that is recording the detailed information of the translation instance. So here I'm including a kind of screenshot of literally the JSON object returned by the translation API, where you can see that they have translation ID, but also title of the article in the source and the target language. And this is article about some museum. Then also the source language, English in this case, also target language in Spanish. So really we thank the transparency of Wikimedia Foundation. They release such detailed information so that we make this study possible. Then we combine this with other data like wiki data, and also language agnostic topic classification. Right? Remember that we're dealing with a lot of different language. So this topic classification has to be language agnostic. And this is a work by Isaac Johnson. I think he is also on the call, and other like article related information, right? And editing and deletion and so on. All right. In terms of empirical strategy, as I mentioned before, the causal identification relies on the partnership between Wikimedia and the foundation and Google. Right? This is a nature experiment design, and we employ different style estimator. So I will kind of be very quick on this part, given the time limit. Also, the audience have a different background, right? The key idea is we're interested in causal effect. So we want to contrast what we observe the factual outcome with counterfactual, where in hypothetical words, what it would have been if there's no Google Translate available. So we leverage a different type of variation in our modeling techniques. So here is a timeline of the Google Translate integration. There's control language where there's either Google Translation support, right? After filtering, we have 42 control language. In treaty language, they have Google Translate integration. So the majority of them is happening in January 2019. But there's few of other language stretch into later 2019 and early 2020. Okay, for model estimation, again, I'm gonna skip this part, but the key message here is that we try different state-of-art modeling techniques. They give us very consistent results, so our results are robust to different modeling choices. All right, for the results, first of all, in terms of translation volume, right, just about how much new content were created like due to Google Translate. We found that Google Translate lead to 71 more articles translated per language per month, right? That's a lot, right? That's 149 further increase, so more than double from the pre-integration baseline. So we kind of, maybe you expect that Google Translate is better, so there will be like more content created because of this, but the increase to such bigger degree is still surprising, at least to me. Right, so our model also passed different diagnoses like parallel trend test and placebo test, right, which add to our confidence in causal interpretation of the results. All right, so that's overall increase in volume, right? That's sort of a big deal, but we want to go above that, try to look at like knowledge gap, right? Since that's of our motivations. So for this part, we're gonna zoom in to specific type of article. We're gonna look at the gender of biographical article and the geography distribution in geolocated articles. Right? They are the two most prominent content gaps. They also make up to almost half of all the translations. Okay, gender content gap first. So I want to clarify here. So we're talking about the gender of the person being featured in biography article, right? Like here in this example, Rani Mukherjee, which is an Indian actress. So this is the gender of the biography article, right? We're not talking about the gender of the editor who contribute to Wikipedia, which is also interesting, but it's not the focus of our study today. Okay, if that's clear, I'm gonna show you the modeling results. So we found that Google Translate integration needs to increase in biography article for both, like for male, female, and non-binary people. But the increase in male is much bigger than female, right? You can see here the coefficient, one is 7.2, the other is 3.8, right? So it's almost double. Right, so for this result, when I just see this regression result, right, I was like, I thought, okay, wow, it seems like this is increasing the gender gap. But upon further reflection, I think there's more nuance to it. And the nuance is we have to consider the initial challenge and the initial context when we're contemplating on this uneven growth in gender representation. Right? By that, I mean, the initial gender distribution of biograph article was heavily skewed. Right? If we look at English Wikipedia in January 2019, for example, among all the biograph article, 72 of them are about males, right? Only 17 about females, and 0.1% is about non-binary individual, right? So this is like it is very heavily skewed. I was shocked by when I first see this number. When you look at biograph on Wikipedia, 82% of them are males. So that is a problem to begin with, but also a problem we should consider here, because given that a translation need to it doesn't come out from nowhere. It need to translate from existing knowledge stock. So given this, maybe expecting equal translation ratio is a kind of too demanding or unrealistic, right? Maybe even though it might be the goal we want to work towards, but this is very high bar to achieve at this moment. So we implement a symbol simulation as a null model to serve as a benchmark, right? As another benchmark other than 50-50. In this simulation, we assign gender to each translated biograph article in our sample. Right? And the way we assign gender is based on just mirroring the observed gender probability of the biograph article at the moment. So that is kind of our knowledge stock when translate. Then we aggregate translation into a panel data set that capturing translation volume by language months for male, female, and non-binary categories. Finally, we apply difference estimator to this simulated panel data and do it 100 times, right? So that we can have point estimator as well as a confidence interval for this distribution. So here, I'm showing the result in these 3 small panels. Right, let's focus on female biography, which is in the middle panel for the moment. So we are comparing the actual, which is a green dot with simulated. And the finding here is, okay, even female biography translation increase is lower than male, right, which we also see from here, but it's higher than the simulated results, right, which represent a benchmark where we only consist existing like gender distribution. So I think the message here is it's an improvement, right? It's not converged to the ideal place, but it's converged to somewhere better than status quo. All right. Then for geography content gap, due to the time limit, I won't go to the detail, but basically we did a very similar analysis as a gender content gap. And the key finding here is like regions with high linguistic diversity, right? Like Asia, like Europe, in those regions, they experience higher content growth in geolocated articles, which kind of makes sense since machine translation is more useful when you have a lot of different language in a very close, like a small region. So they are in a better position to benefit from machine translation. Right. So I have more results on heterogeneity in information flow between source and target language in the paper, where you'll see that English is the major source language and with the implication of that and so on. I don't think I have enough time to talk about here, but if you're interested, please check out the paper and also we can talk offline. So finally, conclusion on the discussion. So I think overall, we found a pretty promising picture, right? We found that this better technology lead to more content production via translation. So that is good, but also we want to like cautious against like there are existing inequity in representation, right? That's something we should think about. At least for me, it started got me to think about, okay, the content cannot come out from nowhere, right? What exists now will impact what can be generated later. I think this is true for machine translation, but also true for like more generative AI. Finally, this research calls for design consideration and careful evaluation in deployment of AI technology. Yeah, I have one more slide. Just want to briefly mention the next step for me of future work. Right, when doing this research, I often been asked by friends and colleagues, right, are this like their question basically, are those new content meaningful? Right? Is it beneficial to have more content in more languages? Well, to me, having more content provision, having better representation itself matters, right? But I guess if I have to answer their question, the approach will be we need to look at usage data. In this case, it's an article page view to see how valuable broad availability is. Right? The idea is I want to use demand estimation to be able to better calculate change in consumer surplus from having content in more languages. Right? That is on consumption side of those new contents. Okay, without that, I'll just stop here.
Thank you so much, Kai. Great presentation. I love this, just, getting into kind of some of this first data on the actual impact of these tools. It's really exciting to see like the scaling up actually happening. At this point, we're going to open it up for questions. I believe we're going to start with a question from Layla. So go ahead, Layla.
Thank you so much. Kai, welcome back. Dylan, great seeing you. Thank you so much for the presentation and for all the work. I have one question, Kai, for you, given that you think about this space a lot, and for going back to the slide where you talk about perpetuating existing inequities. And I want to ask, what do you think the role of recommendations or other mechanisms for nudging editors should be for potentially balancing some of the inequities that we see that we may be perpetuating?
Right. That's a really good question. I think for recommendation system, there have been a lot of research on recommendation system, right? So it's a quite complex question. The consideration here is multi-dimension, I would say. So I cannot comment on what is the current recommendation system like relies on as a factor to make the recommendation, but seem like to me, one factor we should consider is popularity, right? By that I mean we should not only recommend the most popular stuff, because that reinforces what is existing in the system. But yeah, I recognize that probably recommendation play a quite important role also here.
Yeah, and just to maybe just expand my comment if it's helpful for our thinking, and I know others in the team may also eventually want to pick this up and comment on it, or folks online. I think I don't expect, as you say, like a very clear-cut answer, right? It's a complex problem, but each time we run into the question of perpetuating existing inequities, we will need to ask ourselves the question of what are the things we can do to potentially make that different. One would be not offering some. One extreme end would be not offering certain pieces of technology. Another would be to mix certain types of technologies or social solutions to try to reduce some of these inequities. Thanks so much. Yeah, I'll pass it back to Isaac.
Yeah, thank you.
Thank you, Layla. I have some thoughts in that space too, so I'm going to put a pin in that because I think that's something we'll want to return to at a later point. But I know, Gina, you have a question, and we have one from YouTube too, so I'm going to keep us moving through the questions to make sure we get through some of these. Go ahead, Gina.
Hi, Kai. Thanks so much for that presentation. I enjoyed that a lot. And I would also echo your congratulations to Wikipedia and Wikimedia for having rich metadata about these corpora. Very many corpora don't. But I wondered if in your work you had any wish lists of metadata you wish was there that you could have tied together. Like, for example, if multiple languages translated from a source language, same article, would you want to see like the tree of those? Or say there was a, article X got translated to this language and then it got translated from that language to another. Those are just some thoughts, but I wonder if you have others.
Right. So I do have a wish list about data in this scope of research. But actually that's related to the next step where I talk about consumption of Wikipedia pages. Right. So here, when look at consumption, one major question like intrigue me is like who consume the page, right? In particular for like smaller language. So is that well, because when we think about welfare, is that the case that it's the the country where this language predominantly being spoke that become to assume consuming this language, consuming to this language edition of Wikipedia, or is it like kind of page view comes from all over the world, right? So to study that question, we need kind of data about page view by country. So I know Wikimedia Foundation just begin to release this style of data, which is really great. But just in my cases, at least, some of the article wasn't super popular, right? But to be including in that page view by country data set, it had to be the page view need to pass certain thresholds. So for a lot of article in my sample, I still couldn't do that. Right, so that's something I know because of privacy concern. That's why the way Wikimedia Foundation released the page by country data. But just that's one of the things. Thanks for the question.
Thank you. We've got a couple questions from YouTube. Eli, do you want to take a swing at kind of bringing these into the room for us?
Yeah, thanks. Thanks, Isaac. So we've got a number of questions coming in. I'll do my best to try to synthesize the best I can here. Let me just start with a relatively straightforward one. The comment is, first of all, thanks for a very interesting presentation. My question would be about references. What are the implications and dangers in the target article being built from the same sources as the source article? Is this a topic you'd like to comment on, Kai?
Sorry, I don't think I follow that question.
Yeah, the question is pertaining to what the implications and dangers might be in the target language, in the target article, based on the fact that it's being built from the same sources as the source article. And maybe you could comment on any analysis you've done that have looked at references or not.
Right. So that's a really great question. So the thing I kind of skip a little bit is where the source concentrated, right? Where we found that English is a major source language. So it's not just major language; it's actually 73%, the 70 to 80, if you depends on how you cut the sample. So a lot of content is translated from English, right? So it's difficult to like interpret this, right? Is it good things or bad thing? I mean, on one hand, we have to remind ourselves like English Wikipedia is the most developed one, the most have highest coverage. On the other hand, kind of we would concern a little bit about kind of I don't know, English imperialism or like the export of view of point of view. So yeah, I mean, it changed between not just content, but also if you think about some content, you can assign country to it, right? If you think about politician in US, it's a kind of this is have local property or attribute to that article, right? So I think here it need to more study, which I found very interesting.
Yeah, thanks, Kai. Isaac, do I have time for one more? Do we need to move on?
Yeah, let's do one more and then we can switch over to Saeed.
So I want to acknowledge as well that we have a number of questions. We won't get to all of them. There's a number that seem to pertain to the general topic of information flow, which might be unsurprising. But one person in the audience does note that in some sense, it seems that a major benefit of assisting editors in translation on Wiki is to expand the points of view that are represented. Would you like to comment on this? And they note, after all, much of the world can already access content in their own language via on-demand translation from existing articles in other languages.
Well, I don't have empirical evidence to either support or refute that point, right? But I think it can go both ways. Right? Often the case, sometimes I will be also surprising when the translation happen is actually some local concept about the target language, but somehow it's not exist in the target language yet. It's first exists in English, but then it got translated back. Right. So without further empirical kind of investigation, I cannot say much, but I wouldn't just jump into like I wouldn't just immediately come to the conclusion this is like one way information flow, right? Actually, in some anecdotal evidence, I often see it's actually like mutual information flow. Yeah, that's all.
Thank you, Kai. Just as a tailing comment on that too, as you mentioned, content translation came out in 2015. I've been really excited to see some of the kind of advances and additions there that team is adding to that tool. So in recent years, they put out section translation, which makes it a little bit easier for some of these kind of smaller scale information flow shifts. And I hope that also kind of leads to, I guess, like more interesting dynamics of content, not just flowing perhaps in one direction, but flowing in many directions around the wikis. And very recently, they've also been piloting language translation for readers, which I think does open up some really interesting spaces, because if you want to make that content available, you're no longer constricted to just actually creating the article. There's kind of opportunities on Wiki to surface content without it actually being created. So I think that's going to make some very interesting dynamics, and hopefully your research will continue in this space and continue to kind of help us understand what's actually happening out there. But at this point, Saeed, I'm going to give you the floor so that you may present on your work.
Thank you. Okay, hello everyone. I'm Saeed Al-Shahrani, a PhD student at Clarkson University, and I have here my PhD advisor, Professor Gina Matthews, and we'd like to talk about the implications of using inorganic content in Arabic Wikipedia editions.
Hi, everyone. So as we know, NLP is increasingly being used in big decision-making systems, critical decision-making systems about our lives, like resume parsers and things like that. And there's a lot of benefits to systems like that, but systems like that can also learn a lot of biases from the training data. So understanding where your training data came from is super important. And for example, if you're using machine translation, and then someone trains on a data set, say in Arabic, they may think, oh, I'm going to be learning sentiments and bias from Arabic speakers, when really you might be learning it from the authors of the underlying articles. Go ahead, Said. So, as I was saying, these corpora are conveying social concepts. They're not just providing access to information for readers. They're potentially serving as training data for these systems. And when we do translation, we may be losing the views, the values, the culture, the heritage, the perspectives of native speakers. Next slide. And Wikipedia is a really great place to study this and understand this. Wikipedia articles are one of the most widely utilized corpora data sets for NLP systems, especially when you're talking about multilingual content, over 320 languages represented. And as we were talking about with the last paper, just a rich set of metadata that many corpora out there don't have at all. Next, please. In this study that we're going to be talking about today, we're going to be specifically looking at the 3 Arabic Wikipedia editions, but we've been doing research on Wikipedia corpora going back about 6 years in other languages as well. But here we're going to be focusing on Standard Arabic Wikipedia, Modern Standard Arabic, Egyptian Arabic, and Moroccan Arabic. And this is actually a really interesting set of corpora, because the Standard Arabic one is really large. and has a substantial amount of labeled bot activity. The Moroccan is very small, but also has a sizable amount of labeled bot activity. The Egyptian one is very large, does not have a high level of labeled bot activity, but has a very high level of automated translation that is not really labeled in the metadata. So really fascinating set of things to look at, but lessons that apply beyond Arabic. So the problems are going to be that we're talking about are going to be increasingly relevant, because with generative AI, we're going to more and more be seeing content that's generated not by humans. And it's going to become increasingly difficult to differentiate between human generated and machine translated or machine generated texts. And yeah, next slide, please. So here we're going to study the representativeness of those 3 Arabic corpora as NLP pre-training data and the implications of those different types of inorganic content, whether it's labeled bots or whether it's registered users using various types of machine translation.
Yeah, we started our study by analyzing the Arabic Wikipedia editions. And our methodology was when we need to perform a different level of analysis of these 3 Arabic Wikipedia editions. And also we use the English Wikipedia as our benchmark. And the second objective or methodology that we aimed for is that we document the problems and identify the inorganic unrepresentative content in the Arabic Wikipedia editions. So we started by collecting general statistics or metadata. And our hypothesis that we have when we started the study is that the older the Wikipedia, the more metadata that have, or kind of like the metadata, especially the articles. And we can see that Egyptian, English and Arabic, then Egyptian, then Moroccan. But one thing that doesn't fit this hypothesis is the number of the articles of the Egyptian, where it has kind of like nearly 1.6 million articles, but that actually doesn't kind of like represent or aligned with the other metadata that we collected. So we had to investigate this more. So in order to investigate that, we kind of like plotted the pages to date, all the total of pages for these Wikipedias, specifically the content pages over the timeline of Wikipedia. And we see that the English and Arabic are kind of like growing kind of like nicely and exponentially over time. But if you look here in the green, you see that the Egyptian, by the end of 2019, it has only 20,000 articles. Then 2 years later, or less than 3 years, it has nearly 1.6 articles. So we knew there is something with the Egyptians, so we wanted to investigate more, and we studied the content pages and non-content pages. And at the first glance, you see that English and Arabic and Moroccan is kind of like having more non-content pages and less content pages. And this is the beautiful nature of Wikipedia. Like in non-content pages, people or collaborators or editors, they discuss their articles. They have we have talk pages, discussion pages, project pages. So basically, in order to generate these articles, a lot of non-content or human interaction content is generated. But for the Egyptian, this wasn't the case. So we see kind of like less human interaction and more kind of like articles created. So we knew that there was a problem with the articles of the Egyptian Wikipedia, but we wanted also to investigate who's responsible about these large activities. And we see that the English and the Egyptian have kind of like the registered users kind of like contributing to their contents largely. But when we compare English and Egyptian, there is no comparison because English has more than 44 million registered users, and it's the oldest and the largest one. But for the Egyptian, it was established in 2008 and has less than 200K registered users. And also another thing that we noticed is that the Arabic and the Moroccan Wikipedia have a substantial bot activities on its pages. So we went deeper in our analysis. We know there is a problem with the articles, especially the content pages, and also we know who's responsible about it. So we plotted the new pages over the timeline of these Wikipedia editions in a study, and you can see here in the green that the Egyptian has a lot of huge spikes, especially kind of like in July 2020, there were created more than 250,000 articles in 1 month. But when we look at the number of the active users in that month and compare it also with the number of registered users, this is actually doesn't add up. And this is kind of like anomaly and also an evidence that there is a large scale automation going on. So specifically to English, we found to the Egyptian, sorry, we found that over 1 million articles in the Egyptian Wikipedia has been automatically created and automatically translated from English by 1 registered users. But the problem is that all these are done without a human in the loop or a human revision or supervision or even involvement. And the document problems overall for our study is that we documented that there is a large scale unsupervised template-based creation of articles, and also a large scale and unreviewed template-based translation of articles. And these are kind of like occurring on the Egyptian Arabic Wikipedia. And also there is a high percentage of articles labeled as bot created or bot edited articles. And this is limited to the Arabic and Moroccan Wikipedia editions. So after that, we wanted to demonstrate to the community that these organic content could actually impact the performance of the NLP tasks and systems. And our methodology for this study is 1, measure the performance implications of using these unrepresentative content, and also investigate how the pre-training corpora and data sets produced, whether organic or inorganic, could influence the performance of the NLP tasks and systems. So for the experimental setups of our work, we intrinsically evaluated 2 NLP upstream tasks. We chose upstream tasks because they are not influenced by other things like the fine-tuning over the, we chose it over the downstream tasks. And these chosen tasks are word representation using the word embedding models and language modeling using the masked language models. And each of these tasks are actually evaluated using the word analogy and fill mask evaluation tasks. And also the goal of these evaluation is to measure first the impact of template-based translations and also the impact of bot-based generations. And for the experimental setups for the evaluation task, for the word analogy, we target, as we said, the word embedding models. And the format is to solve the word analogy. And we created a data set for that. We call it Arab States Analogy Data Set, a set. And also for the fill mask evaluation, we target the masked language models. And the format here is we mask a token and ask the masked language model to answer that masked token. And we created a data set. We call it Masked Arab States Data Set method. And for the first study where we want to measure the impact of template-based translations of word representation task, we trained 5 context-independent word embedding models on each Arabic Wikipedia editions corpus. So we have 5 models for Arabic, 5 models for Egyptian, and also for Moroccan. And here is the statistics of the corpora used for training these models. And we evaluated these word embedding models using the word analogy task on our ASAT data set. And we found that all the word embedding models that have been trained on the Arabic Wikipedia corpus are outperforming the models that have been trained on the Egyptian and Moroccan. But here, when we focus on the Egyptian and the Arabic, we know that word embedding models have seen more articles than the Arabic Wikipedia edition or models, but this is something that we could kind of like draw here, is that these template-based translations may enlarge the total number of articles, but they will not provide a good performance. And a tiny thing to mention here is the best performing Egyptian word embedding models even cannot compete with the worst performing Arabic word embedding. And here is the overall idea here is that we can see that the template-based translations could actually impact the performance. And for the other parallel study of measuring the bot-based generations, we trained 5 word embeddings, but this time we only do it on the Arabic and the Moroccan, and we drop the Egyptian because Egyptian doesn't have bot-generated articles or bot generation activities, and we also exclude the bot generated articles from the corpora of these models. So we evaluated these word embeddings using word analogy again on a set data set again, but in this time, each model is competing with itself, with another version of itself, where one version is trained with bot-generated articles within its corpus, and the other version is with no bot-generated articles in its corpus. And we see that the overall result is that most of the word embeddings that have been trained on corpora with excluding the bot-generated articles outperform or at worst offer on-par performance to the models that have been trained with bot-generated articles in its corpus. And one thing to draw here is that including these bot-generated articles could influence the performance of NLP tasks. And for the Moroccan models, we see kind of like a similar thing, but most of these models have been trained with bot-generated articles, are performing on par with these models with no bot-generated articles included. And for the other NLP task, language modeling, where we measure the impact of template-based translations, we trained 3 masked language models of architecture Roberta base, and we emphasize on from scratch because we did not use pre-trained models on each Arabic Wikipedia edition's corpus, and here is our hyperparameters. And also we trained a tokenizer from scratch on these corpora as well. We evaluate these MLMs using fill mask task and on our MESAD data set. And we can see that the Arabic Roberta or Roberta based model that trained on the Wikipedia articles is excelling and outperforming the other Egyptian and Moroccan Roberta. We know Moroccan are very small corpora and very young. It was established actually in 2018. But when we compare the Egyptian and the Arabic Roberta model, we see that the Arabic is showing a really great performance, and there is a huge differences into performances, even though that the Egyptian Arabic Roberta based model have seen more articles than the Arabic Wikipedia model. And for measuring the impact of the bot-based generations, we also trained another masked language models of Roberta-based models following the same hyperparameters from scratch, but we also use the same methodology. We only train it on the Arabic and Moroccan Wikipedias, and we exclude the bot-generated articles from that. So our results for these masked language models using the fill mask on MESAD data set, we see that the Arabic Roberta models with bot excluded outperforming the performance of Arabic Roberta base model with bots included. And for the Moroccan, we did not see improvement, and this is reasonable. But this is one thing that we could emphasize on is that these bot generations are actually impacting the performance of NLP tasks. And we finally argue that the automatic paste generations on the Arabic and Moroccan Wikipedia produce unnatural, inorganic, unrepresentative corpora that actually impact the overall performance of the NLP upstream tasks. And this is luckily is caught by the current Wikipedia metadata, but many other pre-training corpora lack this metadata. So thank you, Wikipedia, for offering this. And we second argue that this automatic template-based translations on the Egyptian Wikipedia produce poor, unlimited, and unrepresentative corpora that indeed impact the overall performance of NLP upstream. And this is unfortunately is not caught by current Wikipedia metadata.
So to wrap up some of our recommendations, we would recommend avoiding using translated or automatically generated corpora when the goal is representation-based tasks, like capturing opinions or stances or sentiments or bias or perspectives of native speakers. That's not all the reasons you would come to use a Wikipedia corpora. So we don't have any problem with there being other kinds of content in there. We would just love it to be marked in the metadata so people can avoid it if it doesn't fit the purpose of their task. And we would love to see Wikipedia have another category, which is registered users employing automated creation or translation processes. Even just that category would be great if there was even ability to get a little more fine grain, like whether it was a translation automation or it was another kind of automation. It would help us begin to understand what kinds of automation still result in high quality for different things and which types of automation reduce quality for certain types of tasks. Again, it matters the type of task. Okay, next, please. So in conclusion, we've seen that automatically created, generated, translated articles without human revision or supervision can generate content that impacts the performance of NLP tasks substantially, and also that lacks cultural richness and meaningful representation of the human languages involved and their native speakers. I would really like to emphasize that this is not in contradiction to the last presentation we saw. The issue that was mentioned about there being a barrier to unequal access to information and resources due to language barriers. We are 100% in favor of addressing that barrier. You can do both as long as you label the things with their provenance, where they came from, so that when you want an NLP task that is going to capture perspectives or sentiment or bias or whatever, you can focus on the human created things. And I'd also just again like to say that I think this is going to be more and more of a problem. And Wikipedia is in a great position because they have great rich metadata already. We might have a wish list of other things we want, but already it's so far ahead of other corpora. And LLMs are getting hungry. There's this discussion of like, is there even enough data out there? Are we going to start feeding LLMs synthetically generated stuff? I think there's a lot of benefit to labeling the things that came from humans with humans and labeling things, different kinds of automation tasks, so that we can begin to sort out. We don't just have this lump of a corpora that we don't actually know where it came from, or able to get back to the pieces we need for various purposes. Okay, next. Here's just some easy links to the 4 papers that we mentioned today. I also put in the chat and YouTube some links to some other papers. Some of our other work is not exclusive to Arabic. We mentioned Arabic and English today, but we've done some work in Chinese and Spanish and German and French and Farsi and Urdu and Wolof that is published. And also we've been looking at other languages like Vietnamese and Hindi and other things that isn't in published work yet. Okay, next. And Saeed, why don't you take over at this point?
Also we kind of like released to the community online applications. One application was kind of like serves as a dashboard application where we show how the Wikipedia editions are generated and edited, and it's also hosted publicly on the Hugging Face Hub. And our latest work was about finding a way to automatically detect these template-based translations on the Egyptian Wikipedia. And we published this piece last May. And also we released our best performing model also as an online application, and we call it Egyptian Arabic Wikipedia scanner, where you can search or look for an article and see that if it's a human generated article or template translated articles. And we did it by leveraging the metadata that Wikipedia offered. And again, thanks a lot for this, because it was really helpful to come up with multivariant classification algorithms to help us address this. Thank you.
Thank you both for this wonderful presentation. It's got so many thoughts spinning around my head. Gina, I was really appreciating a point you were making about the different audiences and how that impacts kind of what you do with this. And I was, there's like readers on one hand who maybe are okay with like lower quality content because, hey, it's readable, I'm getting the facts I need, but that could be very different from the needs of like patrollers on the Wikimedia projects who are trying to understand like, where do I put my efforts around vandalism detection, like looking for potential misinformation or just like fixing small kind of copy edit errors, which would be different from AI developers, which is, I think, a lot of the focus of this presentation, thinking like, how do I use this as a large like corpora in general to understand language, which is different from like Kai's work, which, computational social science folks in that kind of space. So trying to understand these dynamics on the wiki. So just a lot of thoughts, and I think we'll get to that. Actually, I think Kai, you have a question, and I think it's a good one to start with because I think it focuses too a little bit on your kind of intended audience around kind of AI developers and like, okay, you have this corpora that you have a starting corpora. Like, what do you do with it? How do you make it more representative? So Kai, I'll pass it off to you.
Yeah, so my question is a simple clarification question. So it's about when you compare this different model, like what embedding model, also later Roberta model, right? Just wonder the volume of each corpora, are they different, or you equalize because they are different, right? But my question, I guess, is, did you equalize the size of training corpora with sampling, so to make them equal size?
Do you want to take that, Saeed, or do you want me to?
Yeah, you can go ahead, Gina.
So the corpora, yes, are very different sizes, and no, we didn't equalize by sampling.
Okay, so I think the more fair comparison would be to look at the corpora of them size for training, because otherwise, like what embedding model, for example, they benefit from have a bigger training corpora, right? So I thought that may be something to consider.
I agree, that would be an interesting comparison as well. I think the one we did is also interesting, but I agree that would be interesting too. And thanks for that suggestion.
Yeah, I do have a comment, Gina. Yeah, we did not kind of like equalize it or kind of like sample it, have an equal sampling. And we did that on purpose, actually, because the intuition that we have it here in the NLP community, that the bigger the corpora, the better the representation. And this wasn't the case with the Egyptian. And we wanted to make a case that it doesn't matter how big your corpora is, it's about how representative your corpora is. So we saw that, for example, in the case of the Egyptian, it has 1.6 million articles. And these models, some of the models that trained on the Arabic Wikipedia, or most of the models trained on the Arabic Wikipedia with different tasks, even though they've seen kind of like a small corpus in size, they outperform these models. So I think this was the reason we want to show these, that bigger is not always better. Kind of like large corpora is not always better in terms of representation. But if we equalize them or kind of like sample them equally, we're going to lose this argument. And this is why we did that.
Do we have another question? Or I could also just say that emphasize that I think if we'd sampled down to the size of the Moroccan for the other two, we would lose other things that we wanted to see. Like what we are seeing is that you need both big and organic, both, to be successful for many NLP tasks. But I agree that what you suggested would also be an interesting experiment, just a different one. And thanks for that suggestion.
I think we're going to move to Miriam, but I think this is also a good point. There was some related work I'd shared with you all too that I think shows just how like this how important it is to be studying this, because if you look at the internet at large, folks are seeing a lot of these same dynamics of a lot of the content being present in other languages is often translated, especially for some of these under-resourced languages, is actually often translations coming out of English. And you know, the AI community definitely needs to reckon with what that means as far as the representativeness and how to handle just how messy and noisy that data is. But Miriam, I believe you have a question, so I'm going to pass it to you.
Yes, thank you. Thank you for this wonderful presentation. I really love your advice at the end and your encouragement to label content at the source that is basically produced automatically. One question I have is your recommendation is also maybe not using content that is produced automatically in certain NLP tasks. I'm wondering if by incorporating labels, we can actually essentially suggest the models that this is different information and that the models can treat it differently and still, extract the necessary information. If properly trained, you might exploit all the corpus information without necessarily excluding knowledge that might be useful for some of the tasks.
Yeah, that's an excellent point, Miriam. If the label's there, then a given LLM could say, I'm going to discard things that are tagged this way, or could say it's going to weight them less, or it's going to do this or that with them. I don't think that those are mutually exclusive. So yes, leaving them in and then saying you can include, but with a different weight or something, very much in line with what we're saying. All would come out of having that tagging available. Thanks for that question.
Dylan, I believe you're next, so go ahead.
Yeah, I just had a sort of a broader question about measuring the quality of corpora based on the performance of, machine learning tasks trained on that corpora. And I mean, to me, that's an interesting idea. And I don't know if conventionally, maybe this is a really common thing that is done. But if the tasks are not diverse enough, right, then what looks like it may be a poor quality corpora could instead be attributed to just a corpora that's not designed well, or doesn't fit well with the tasks that you're looking at. And so I just wondered, like, are there benchmarks out there that look across? Like, I know there's MTEB, for example, that sort of measures the quality of embeddings across a litany of different different tasks. How does this compare to something like that?
That's an excellent question. And I think it really gets back to what Isaac was saying about the different audiences. Quality is in the eye of the beholder, right? Quality for what? Quality to who? And so there's an infinite number of tasks you could imagine bringing to something. What we're just showing is that for some tasks, it actually matters whether it was human generated or auto generated or template or different in ways. And mostly what we're arguing here for is more labeling, so that for whatever the purpose is, you can make a good decision. And for any corporate out there that's just a big old corporate with no metadata, we're pointing out that there's probably lots of problems like this there. Here, we're able to filter out some things when they don't match our purpose. And yes, to more benchmarks, more definitions of quality. I just think that'll be a never-ending possibility of things you could add there.
Yeah, I agree. I also really like the question. I'll say that personally, I've been thinking a lot about what are the benchmarks from the Wikimedia side, like what are the ones that are important for us understanding whether these corpora are doing given that a lot of these language models are being trained on this Wikipedia content, how do you say then, okay, like, are these models actually being valuable for Wikimedians themselves? And I think, yeah, there's a lot. We could take that, and we might actually have a future showcase around data sets and benchmarks. So I'll just flag that as something we're thinking about and want to return to in later months. I had a question, actually. I was interested in this. So on the projects, you often see this kind of cleanup process happen. where you maybe have like an initial translation, and then after that for a little bit you'll see editors come in, and maybe the original editor, and do some cleanup actions. And I was kind of curious, and this also gets to some of the policy on the wikis too, because editors for the content translation team in certain language editions, or the content translation tool in certain language editions, have set thresholds by which they expect the machine translated content to be changed. So they'll say, like, at least 25% of this content must be edited in some way, for instance, in order for this translation to be publishable. And I'd be curious, Gina, from your perspective, looking at these translations, like how much adjustment, how much cleanup has to go on before we start to move into this like more representative of the language, more kind of natural text? Like what should we be thinking about there as far as kind of cleanup of these raw translations?
Again, I think there's no one right answer to that. If what you wanted was to gauge sentiment or bias or whatever, and you translated from an English corpora into Arabic, and then you said, what are the biases here? Like social construct kind of biases, you probably would just be pulling those ideas from the English speakers if you got a really good translation. And that still might not be what you want, depending on your task. I love the idea of kind of trying to study the pattern of, like, say you began with a translated article and then you have a series of edits, what percentage has been edited, at what point it starts to become useful for various purposes. I doubt there's one right answer, but I think there's a lot we could begin to learn about, and that might shift over time with the quality of translations and all sorts of things. We had a little bit of conversation leading up to this about the template-based translation. There being some people say it's better to start with a template, even if it's kind of yucky, because it's easier for a native speaker to come and improve it than it is to start from scratch. And we could go back and look at the evolution of those articles, how many of them did draw further edits, and then what that looked like. I think there's a lot that could be studied here about the process, and the more tagging we could do about the types of automation, when automation is done, be able to look at the timeline, look at the percentages, the more we'll be able to learn here what bars would make sense for various tasks.
Yeah, I think that makes a lot of sense as far as having a bit more data. And I think your recommendation around better tagging for perhaps some of these semi-automated types of edits too is an important piece of transparency, I think, for a lot of these audiences. I think now I'm going to turn to Layla, who had a good question, I think, on how you engage with the community. And Saeed too, I'll say I appreciated the two pieces you put out for that, like the Hugging Face spaces. It was nice to see that extra effort being taken to kind of make some of this more accessible to those communities. But Layla, I'll pass to you.
Great, thank you, Gina and Saeed. Thank you so much for the research, first of all, and also for the empathetic messaging around the great research that you have done. I think it is important both for us to hear some of the challenges that you see, the NLP community, some of the challenges that you see, and also for us to understand the infrastructure and environment that the Wikimedia communities work in, and empathize with that and try to, do the messaging in ways that work eventually for everyone. I appreciate everything that you said in this presentation. Thank you so much for all the work. I wanted to ask if you have done any kind of underground work to bring some of the learnings that you have had to the communities. This can be Egyptian, Arabic speaking community. The reason that I ask is that for us, it's important, of course, like to hear, as let's say Wikimedia Foundation, to hear some of the things that you have learned, and are on our end. From those learnings, we make certain decisions that over time can make things better. However, in a lot of cases, the change happens faster, more effectively on the ground. And actually, there are spaces in which community has a lot of discretion over what they can do on the ground, which the foundation doesn't have. So I wonder if you have already reached out to the community on the ground with some of your recommendations. If not, I'm happy to offer help on that front, just to help you start that path, maybe if you have interest about it. But I just want to ask you and see where we can go from here.
Yeah, thank you for the question. It's a great question. Yeah, we actually have given many talks about this in many Arabic NLP communities, especially the open Arabic NLP communities. And the message that we want to convey is that it's okay to use translation tools, or Gen AI tools. But you need to be careful when you utilize these tools. You know, it's part of the movement now. We need to use it and utilize it, but we got to be careful when it comes to representation specifically. Like as Kai represent, it's really great work, but one thing is that we're going to have a trade-off between local content on a local content with a global content. Like we're going to translate and have kind of like mirrored kind of like contents across all Wikipedia editions, but we're forgetting something that actually contribute to the representation of local communities. Like, okay, you have a local communities, they should contribute, they should add content. And this is one of the things that we emphasize in the community. And also we reached out to, and we have kind of like collaboration with many kind of like labs in Saudi Arabia and United Arab Emirates, and also a lot of collaborators with us on these papers from different places. But yeah, the message is that these tools are great. Let's utilize them, but let's try to kind of like utilize them the right way.
If I can do a very quick follow-up, Isaac, thank you for explaining that, Saeed. And I'll mention that in my humble opinion, it is also important to have some of these conversations with the corresponding Wikipedia communities, because they can sometimes make changes, or at least they may need to be aware of some of the work that you're doing with the NLP community. For example, categorizing let's say a subset of languages or projects or efforts as things that the NLP community needs to be more careful about. This is a good conversation for the Wikipedia community on the ground to be aware of it, because again, like they have a lot of power and discretion over like how they do things on the ground. So I encourage you to also go down that path if you haven't.
Thanks.
Thank you to our speakers. Thank you, Layla. I'm going to pass it now to Kinneret to close us out.
Thanks, Isaac. And thank you, everyone, for joining today's showcase and entering all your questions and joining us in the discussion. Special thanks to our speakers, Kai, Said, and Jenna. Thank you for your contributions and for being with us today. The showcase is made possible thanks to the coordination team with my colleagues, Isaac, Eli, and Miriam. So thank you all. There will be no showcase next month, as we'll be focusing on Wikimania. So we hope to see you around there, either in person or online. And we will be back in September for another showcase. Looking forward to seeing you all there.